Hi, I'm Audrey Gamble, an Associate Professor in the Department of Crop, Soil, and Environmental Sciences at Auburn University. Today, we're at the Old Rotation, a historic experiment on Auburn University's campus. This experiment was established by Professor J.F. Duggar in 1896, and it demonstrates the benefits of a good crop rotation and cover crops on soil health in our highly degraded Alabama soil types. At the time when Dr. Duggar established this experiment in the late 1800s, there were about 8 million acres in row crop production within the state of Alabama. A lot of the farming practices that were used at the time, like frequent and intensive tillage, really left the soil bare and prone to erosion, leading to severely degraded soils within the state of Alabama. So Dr. Duggar had a vision at the time of establishing this experiment to show that farmers can produce cotton and corn sustainably by using good crop rotations and cover crops. Dr. Duggar was quoted as saying Alabama agriculture will come into her own when her fields are green in the wintertime. So when Professor Duggar established this experiment, he included 6 different cropping systems, which include continuous cotton, cotton rotated with corn, and then cotton rotated with corn, wheat, and soybean. Many of the plots out here also include a winter legume cover crop. So a cover crop is a crop that we grow during times when the soil would normally be left uncovered. And the reason that we grow a cover crop is really to benefit the soil. We're not harvesting it, we're not using it for any other purpose except to kind of build up the soil. Most of the treatments that are out here at the Old Rotation have remained pretty much the same since 1896. We have had a couple of very large changes out here since that time. For example, in 1996, we converted all plots from a conventional tillage to conservation tillage. But in 1996, the USDA Agricultural Research Service Soil Dynamics Lab here in Auburn helped us switch over to a conservation tillage. So really the only soil disturbance that takes place out here at the Old Rotation since 1996 is a strip tillage. So we only disturb a narrow slice of soil that's about 4 inches wide, and then we plant the cotton or the corn directly into that row. The rest of the soil remains undisturbed. So another big change that we had came in 2003 when we divided all the plots at the Old Rotation in half. And half of each plot is now irrigated, so this allows us to compare yields in the irrigated versus dryland conditions. And that allows us to better understand how maybe cover crops or crop rotation are influenced in irrigated versus dryland conditions. There are some smaller changes that we make year to year at the Old Rotation. For example, we look at our local variety trials and we update our cotton, corn, soybean, and wheat varieties based on what crop varieties are performing well for the soils and climate of this region. Soybean was actually not grown widely throughout the state until the late 50s and early 60s. So we actually switched to soybean in 1960. Prior to that time, we were growing cowpea as our summer legume in the rotation. So let's take a look at some of the more specific plots that we have out here at the Old Rotation. So let's start with plot number 1, which is a plot that has been in continuous cotton since 1896. It does not include a rotation with any other cash crops. There is no winter legume cover crop ever planted in this plot, and there's also no nitrogen fertilizer added. So this is actually our worst yielding plot in the Old Rotation, and it has been consistently for decades. So for example, in this plot, we usually yield about 500 pounds of lint per acre in dryland and irrigated conditions. So if you're not familiar with cotton yields, if you've seen one of those bales of cotton on the side of the road, that weighs approximately 500 pounds. So if we look at the soils in this plot, we can see that these are also our porous soils out on the Old Rotation. They have less than 1% organic matter. And if we look at the structure of the soil, we can see that it has a platy structure that does not allow water to infiltrate very well. So overall, these soils are pretty poor in health and low in organic matter. And this is the part of the reason that we have not been able to improve cotton yields in this area within the rotation. So now let's walk over to a plot which is pretty similar in its management. The only difference is that it has a winter legume cover crop during our winter months. So just like the plot we just viewed, this area has been in continuous cotton since 1896, and it has never received any nitrogen fertilizer. The difference between the two plots is a winter legume cover crop like clover or vetch during the winter months. So if we look at this plot, we can actually see the residue that's left behind from the clover that we grew here last winter. So what we do in these plots that have a continuous cotton rotation but a winter legume cover crop included is in the fall, once we harvest the cotton, we'll actually go in and we'll plant either crimson clover or hairy vetch. In the springtime, we'll terminate the cover crop chemically. So we'll kill the cover crop, and then we'll wait about 2 weeks, and then we'll go in, we'll subsoil. So that'll be that minimum tillage implement that we use that disturbs only the row where the cotton is planted, and then we'll actually plant the cotton right into the row. So that's the only soil disturbance that we get, and we have that 2-week window to really allow the clover or the vetch to degrade so that it's not competing with the cash crop. Because it's a legume cover crop, it makes its own nitrogen fertilizer through an association with rhizobium bacteria. So they attach to the clover roots, and they take the nitrogen which is in the atmosphere and convert it into plant available nitrogen. So the cotton is actually benefiting from having that legume cover crop. It's also benefiting from the improved organic matter in the soil. So in this area, we've moved from about 1% organic matter to 2.5% organic matter, which may sound small, but it's actually a huge difference when we're talking about soil health in Alabama soils. So if we actually dig into the soil in these plots, we can see a much richer dark color. That's from the higher organic matter within these soils. It also has a better granular structure that allows water to infiltrate better. So that organic matter is going to provide a lot of benefits to the cover crop. Number one, it's going to provide basically a slow release form of nutrients. It's going to provide some nitrogen to these cotton plants, which is why cotton in this plot looks much greener and much healthier. It's because it has improved fertility. These soils also allow more water to infiltrate. So we've actually observed with research that these soils will hold about 4 times more water than the adjacent plots, which have lower organic matter and poorer soil structure. If we talk about the economics of this system, in this field we're actually making about 1,500 pounds per acre of cotton lint compared to that 500 pounds that's in plot number 1. And so that we've essentially tripled our cotton yield, and the only additional input that we have is this winter legume cover crop. It does take a while for the benefits of cover crops to kind of accumulate. So, you know, this plot has been in cover crop since 1896 and conservation tillage since 1996. And it's taken us a while to get the organic matter to this level, but those cover crops are really a long-term investment in allowing us to build the health of our soils, build the nutrient holding capacity, and build the water holding capacity of the soils. So plot number 2, which we're in right now, and plot number 3 are actually very similar. They're both in continuous cotton rotation with no nitrogen. The main difference is just the timing of when phosphorus and potassium fertilizer is applied, which after 127 years, we actually kind of assumed we have adequate phosphorus and adequate potassium for our cotton and corn plants to grow. We fertilize according to soil test, so we kind of consider these two plots quite similar. But if we move on down to plot number 4, this is actually where we get into our first summer crop rotation. So this plot has been in a continuous cotton corn rotation since 1896. It also really receives no nitrogen fertilizer. just like those plots that we looked at previously, but it still does get a winter legume cover crop. So our yields are still very good in these plots, and we still have high organic matter. In fact, our organic matter tends to be slightly higher in these plots with a cotton corn rotation, and that's because the corn, once we harvest any of the grain from the corn, all of this good plant material and residue is left out in the field, and that contributes more organic matter to the soil. So when I say organic matter, really I'm talking about anything that was once living that is now a part of the soil. So any plant residues, any bacteria or fungi or parts of earthworms that slowly degrade and add a carbon source to the soil, that's what's higher in these soils with a better crop rotation and a winter legume cover crop. Right now, this year, plot number 4 is in corn. Next year it will rotate in cotton, and that cycle will continue year after year. So if we compare the cotton yields that we've observed in this plot for about the last 10 years to the previous plots that we've already looked at, we move from about 1,500 pounds of lint when we have that continuous cotton with a winter legume cover crop, and we move to about 1,600 pounds per acre of lint when we average our dryland and irrigated yields. And what that is, we really attribute that to is just having a good crop rotation that helps break up any pest cycles, disease cycles, as well as that improved organic matter from having the corn residue. So this is an example of how the old rotation kind of shows the benefits of a good crop rotation with that winter legume cover crop included. And again, this is still a plot that has received no additional nitrogen fertilizer. Our only nitrogen is really coming from that winter legume cover crop and the organic matter that is mineralizing slowly over time to provide some of that nitrogen. In these plots, after we harvest corn in the fall, we'll come in and we'll plant our winter cover crop just like we do behind cotton. But one big management difference that we have in terms of our cover crop with corn versus cotton is that we'll actually terminate the cover crop right when we plant the corn. That allows us to get the maximum benefit out of our winter cover crop because corn is usually planted a little bit earlier than cotton. That clover cover crop may not have reached its full potential yet if we terminate it too early. So the corn is actually able to withstand a little bit of competition from the clover or the vetch, and so what we'll do is we'll chemically terminate at the same time that we're planting our corn crop, and then that clover or vetch residue will degrade slowly over time and contribute some organic matter, contribute some nitrogen to the growing corn plants. So if we move to plot number 5, plot number 5 is again quite similar to number 4, but now we're actually getting into the plots that contain some commercial nitrogen fertilizer. So this is going to be essentially one of our highest yielding plots when it comes to cotton yields. So this plot number 5 is in a cotton corn rotation, just like the previous plot. It contains a winter legume cover crop, just like the previous plot, but this time we are adding about 180 pounds per acre of nitrogen to the corn crop. And then when this plot is in cotton next year, it will receive 120 pounds of nitrogen per acre as commercial nitrogen fertilizer. So again, we have this residue, we have high organic matter, and when we compare the cotton yields to our previous plot number 4, we can get about 20 more pounds of lint per acre, which is actually not that big of a difference. When we think about cotton lint prices and nitrogen fertilizer prices, in most years, it's actually having that extra nitrogen fertilizer is not going to pay for the added yield, cotton yield that we get in this plot. Let's dig up a little bit of soil in this plot since it's one of our high residues. So again, this is one of our plots with highest organic matter. We're about 3% total organic matter in this area. So the cotton corn rotation with the winter legume cover crop really tends to be the highest organic matter, best in terms of water infiltration, nutrient cycling, all of those good properties. You can see lots of roots in this soil as well. That's left over from the legume cover crop, and that's going to slowly degrade and add some additional organic matter to the soil. So if we continue on down the plots, We'll actually see a lot of treatments that are replicated, so they're actually out here more than once. So plot number 6 is the same as number 1, where we have a continuous cotton rotation with no winter legume and no nitrogen fertilizer added. Then plot number 7 is the alternative to plot number 4. So 4 and 7 rotate between cotton and corn every year. So this year we're in cotton, next year it will be in corn, just like plot number 4 will be in cotton next year. So very, very similar yields in these plots to plot number 4. If we move on down to plot number 8, this is actually the same as plots 2 and 3, where we have continuous cotton with that winter legume added. So plot number 9 will be the same as plot number 5, where we have the cotton-corn rotation with a winter legume with nitrogen added. So plots 10, 11, and 12 will actually rotate through a 3-year crop rotation. So as you can see here, we have cotton growing. That cotton will be followed by a winter legume in the fall. So after cotton's harvested, we'll actually plant either a crimson clover or hairy vetch. Then the following spring, we'll actually plant corn directly into that legume cover crop. And then following corn, we'll plant wheat, winter wheat, that will be harvested in the following June. And so actually in the 3rd year of the rotation, we'll plant soybean double cropped behind wheat. Then we'll go back through that original cycle of cotton, so on and so forth. These plots are actually slightly lower yielding than some of our cotton corn rotation plots that have a winter legume. We get about 1,300 pounds of cotton lint per acre if you average the dryland and the irrigated. And that's just our 10-year average yields. So we really haven't seen an additional benefit of having that longer crop rotation in this particular area. But we also have I would say less winter legume cover crops, because we only have a winter legume cover crop that's growing every 3 years as opposed to every year like we have in our cotton corn rotations. But we do have that added value of having a soybean and wheat in the rotation as well, which can diversify risk. So moving on to plot 11, this would really be the next stage of that rotation, where we have corn right now. And as soon as we harvest this corn in early fall, we'll go in and plant that winter wheat. And then our winter wheat was actually harvested recently in this plot, and you can see we followed behind with soybean. So we actually planted soybeans in this area about a month and a half ago, or about a month ago. So moving on down, our last plot in the experiment is going to be our continuous cotton rotation. So it's in cotton every summer. But it has no winter legume cover crop, but it does have that nitrogen fertilizer added. So we don't have as many residues in this plot. You can see kind of similar platy structure to some of our previous plots. And it does not yield as well as our cotton corn rotation that has that winter legume added. To kind of wrap up the tour of the old rotation, I think if we look back to what Dr. Duggar established this experiment for, it was really to show the benefits of crop rotation and winter cover cropping. And by having this experiment out here for so long, we're able to look at really how those practices have affected the soils in the long term. And that's very valuable. So in our plots, like we have here, that have been in continuous cotton with poor fertilizer management, no legume cover crop, our yields have really remained stagnant since 1896. But in the plots that do have a good crop rotation and do have a winter legume cover crop, those yields have over tripled since 1896. So we're able to take advantage of some of the newer cotton varieties and the yield potential that those have by having the improved organic matter, the improved soil structure, the improved crop rotation and breaking of pest cycles, all those good things. So I think Dr. Duggar's original mission of showing how good crop rotation and winter cover cropping can benefit the soil really holds true, and we're able to show the long-term effects of that at the old rotation. So it really just remains a valuable site that we're proud to have on Auburn University's campus.